Welcome to the notes on 45, 45, 90 triangles. And really, I should put right triangles. So let's take a look at this first picture, right? There's our right angle. Notice the angles are the same, 45 and 45 degrees. Well, remember, if angles are the same, what do we know about the leg or those sides, the legs of the triangle? Well, if the angles are the same, that means the sides are the same. So these two legs are congruent. And they found that any 45, 45, 90 triangle, if the legs are the same, the ratio of those sides is 1 to 1. So the value is actually the number 1. Put that there so it doesn't look like my tick marks. All right, so then using Pythagorean theorem, what would the hypotenuse be? Well, remember, Pythagorean theorem is legs squared, so 1 squared plus 1 squared would equal the hypotenuse squared, which in this case I'll just call x. Well, 1 plus 1 is 1 squared is 1. So it's 1 plus 1 equals x squared. So 2 equals x squared. So I take the square root. So the hypotenuse then would always just be root 2 compared to those sides in any 45, 45, 90 triangle. So why is that important? Because when we're solving for 90 degree right triangles at 45, 45, 90s, we always want to compare it to the most simple form of 45, 45, 90s. So now that we know those are the values, let's take a look at some examples. So it says find the missing value of variables in the following triangles. Now they only tell us that this angle here is 45, but because we know all of the triangles, all the angles in a triangle add up to 180, this has to be 45 as well. So what are we going to do? Well, for every problem, I want you to draw that standard 45, 45, 90. And you can even draw it in the same orientation, 1, 1, root 2. Now, how are we going to solve this? All right, I said we're going to use proportions. So we're going to compare, all right, what are we trying to solve? All right, in this case, we're trying to solve the hypotenuse, which is A. Well, then I'm going to compare that to root 2 on this side. So A is to root 2 equals, you're always going to use what other pieces they give us. Well, they gave us the 7 on this side, on this leg, so I'm going to compare it to the 1 on this side. So I'm going to get equals 7 over 1. Now the easy part, how do you solve any proportion in the world? That's right, you cross multiply. So A times 1 is just A, and 7 times root 2, well, you can just keep it as 7 root 2. You can give me a decimal if you want, but prefer to just keep it simplified like that. So there is your answer. But notice we're always going to compare it to that standard 45, 45, 90 triangle. Let's take a look at 2 more examples. First thing again, I'm going to redraw it every time, and I'm going to show you that you can even redraw it with the same orientation. So 1, 1, root 2, and I'll put the little 90 here so you can see it. So let's compare, all right? So here's our x, all right? It's the hypotenuse again. So I'm going to compare it to the hypotenuse on this side. So it's going to be x is to root 2 equals, now they gave us this value, 3 root 3. Well, that compares to 1 on this side. So 3 root 3 over 1. Again, I'm comparing the triangle left to right, left to right, left to right, leg, hypotenuse to hypotenuse, leg to leg. And then, hey, there we go. Let's cross multiply. We got the proportion set up. Cross multiply. 1 times x is just x. So now we're kind of right over here. X equals, then we cross multiply this way. All right, so that's 3 root 3 times root 2. Now, radicals or anything under that square root symbol can combine with each other. So these two values right here, we can multiply together. The one on the outside stays on the outside. So you can only combine radicals with other radicals. So x equals 3, root 3 times root 2 is root 6. So there is your final answer. X equals 3 root 6. Let's take a look at one more example, and we'll get you guys started. So again, I'm going to compare. Here's my standard 45, 45, 90. Oops, messed up my drawing there. There it is. 1, 1, root 2. I think you guys got the idea. Now, they don't give us, there's 2 missing ones. Well, don't panic because it's a 45, 45, so we know that both of these have to be the same. So pick one and go with it. I'm going to go with this one. So I'm going to compare x to 1. So x is to 1 equals, now they give us the hypotenuse of each. 5 root 2 is to root 2. So that's where these come from. 5 root 2 is to root 2. Again, now we just cross multiply. So x times root 2 equals root 2x or x root 2. I'll call it root 2x. I'm going to put the x in front. Doesn't really matter. X root 2. A little bit easier to say like that, see it like that. And then 1 times 5 root 2 is just 5 root 2. It's this. We want to solve for x. This is still multiplication. X times, so we're going to divide to get rid of that root 2. Divide to get rid of the root 2. Look what happens over here. It cancels out. So x just equals 5. So if this one's 5, guess what? This one also equals 5. So there you go. That's how you're going to solve 45, 45, 90 triangles. Compare it to that standard triangle. Now here, notice the pattern down here. And I'll get this out of your way for you. Here, the 2 legs are 7. What do you notice about the hypotenuse? 7 root 2. Here, the 2 legs are 3. What do you know about the hypotenuse? 3 root 2. It's root 2 times bigger than the leg. Just like in the standard, 1, 1 root 2. 5, 5, 5 root 2. So if this is 11 and 11, what do you think this is going to be? You got it, 11 root 2. So some of you guys might start picking up that pattern, but there you have our lesson on 45, 45, 90 triangles.